Welcome to Brost Servicing Noise and Hearing Loss. In this module, we will be learning about the differences between sound and noise, how sound is measured, the anatomy of the human ear, how hearing loss occurs, and how work-related hearing loss can be prevented. Noise is any unwanted sound. The difference between sound and noise depends on the listener and the circumstances. The sound of amplified rock music can be a pleasurable sound to one person under certain circumstances, while the same level of sound in the workplace would be considered hazardous and subject to controls. Noise is a major occupational hazard. Short-term exposure to excessive levels of noise can result in temporary hearing loss, ringing or buzzing in the ear, or sudden hearing damage caused by a short burst of extremely loud noise. The long-term effect is permanent hearing loss. Non-auditory effects include stress and problems with oral communications. Both short and long-term effects can be prevented by timely recognition and control of noise exposure. Sound is produced by vibrating objects and reaches our ears as waves in the air. As an object vibrates, it causes slight changes in air pressure. These air pressure changes travel as waves through the air where they cause our eardrums to vibrate. The ear converts these vibrations into electrical impulses which are sent to the brain, which in turn interprets them as sound. The two primary characteristics of sound which are important in the workplace are frequency and sound pressure. Frequency is the rate at which the sound source produces sound waves. It is the number of times that a vibrating body completes one cycle of vibration. The unit for frequency is the hertz. 1 hertz equals 1 cycle per second. Low-pitched or bass sounds have a low frequency, while high-pitched or treble sounds have a high frequency. The normal hearing range for a healthy young person is between 20 and 20,000 hertz. The sound of human speech is mainly in the range of 300 to 3,000 hertz. Sound pressure is the amount of air pressure fluctuation a noise source creates or the amplitude of sound waves. We hear or perceive sound pressure as loudness. Sound pressure is expressed in units called pascals. A healthy young person can hear sound pressures as low as 0.00002 pascals. A normal conversation produces a sound pressure of 0.02 pascals. A gasoline-powered lawnmower produces about 1 pascal. Because this wide range of sound pressures is somewhat difficult to work with, they are converted to another unit called the decibel. As you can see, there is a mathematical equation that is used to convert pascals to decibels. It is not necessary for you to know this equation, as a decibel is the unit of measurement used for workplace noise. The human ear is not equally sensitive to all frequencies. If a person hears two sounds of the same sound pressure but different frequency, one sound may appear louder than the other. This occurs because people hear high-frequency noise much better than low-frequency noise. Noise measurement readings can be adjusted to correspond to this frequency dependence of human hearing. What is termed an A-weighted filter is built into the sound level meter to de-emphasize low frequency. Decibels measured using this filter are A-weighted and are called dBA. Noise regulations typically give exposure limits in dBA. This weighting serves two important purposes. It gives a single number measure of noise level by integrating sound over all frequencies, and it gives a scale for noise level as perceived by the human ear. This table provides a wide range of noises and their A-weighted decibel measurements. A conversation at 1 meter is typically 55 decibels, which is considered a safe noise level. A handheld circular saw at 1 meter distance is approximately 115 decibels. This level of noise can cause damage to hearing. Loud noise can damage your hearing. Noise is considered hazardous based on how loud the sound is, how long the exposure lasts, and how often the exposure is repeated. To understand how hearing damage occurs, we must be familiar with the anatomy of the human ear. The three main parts of the ear are the outer ear, middle ear, and the inner ear. Hearing begins when sound waves pass through the outer ear to the eardrum, which is a thin piece of skin between your outer and middle ear. When the sound waves reach the eardrum vibrates. The three bones of the middle ear are called the ossicles. These include the hammer, anvil, and stirrup. The eardrum and the ossicles work together to increase the vibrations as the sound waves travel onward to the inner ear. Noise and hearing loss. When the sound waves reach the inner ear, they travel through fluids of the cochlea. The cochlea is a snail-shaped structure in the inner ear. In the cochlea, there are nerve cells with thousands of miniature hairs attached to them. These hairs help convert sound wave vibrations into electrical signals that then travel to your brain. Your brain interprets these signals as sound. Different sound vibrations create different reactions in these tiny hairs, signaling different sounds to your brain. There are three basic types of hearing loss, each caused by different underlying factors. The three most common causes of decreased hearing are conductive hearing loss, sensorineural hearing loss, and mixed hearing loss. Conductive hearing loss occurs when sounds can't travel from the outer ear to the eardrum and the bones of the middle ear. When this type of hearing loss occurs, you may find it difficult to hear soft or muffled sounds. Conductive hearing loss isn't always permanent. Medical interventions can treat it. Treatment may include antibiotics or surgical interventions such as a cochlear implant. A cochlear implant is a small electrical machine placed under your skin behind the ear. It translates sound vibrations into electrical signals that your brain can then interpret as meaningful sound. Conductive hearing loss can be the result of ear infections, allergies, swimmer's ear, a buildup of wax in the ear, a foreign object that has become stuck in the ear, or benign tumors or scarring of the ear canal due to recurrent infections. Sensorineural hearing loss is also referred to as SNHL. SNHL happens when there is damage to the inner ear structures or in the nerve pathways to the brain. This type of hearing loss can have many causes, including aging, trauma to the head or skull, and various illnesses, but does occur as a result of working around loud noises. SNHL is usually permanent and makes even distinct, normal, or loud sounds seem muffled or unclear. Mixed hearing loss may also occur. This happens when conductive hearing loss and SNHL occur at the same time. Mixed hearing loss is most often associated with aging. Sensorineural hearing loss, or SNHL, is caused by damage to the structures in your inner ear or your auditory nerve. It is the cause of more than 90% of hearing loss in adults. Common causes of SNHL include exposure to loud noises, genetic factors, or the natural aging process. A spiraling organ inside your inner ear called your cochlea contains tiny hairs known as stereocilia. These hairs convert vibrations from sound waves into neural signals that your auditory nerve carries to your brain. Exposure to sounds louder than 85 decibels can damage these hairs. However, you might not experience hearing loss until 30 to 50% of these hairs are damaged. SNHL can range from mild hearing loss to complete hearing loss depending on the degree of damage. SNHL can occur in one ear or both ears, depending on the cause. If SNHL onsets gradually, the symptoms may not be obvious without a hearing test. There are no surgical options to treat SNHL. The most common options is hearing aids, which help compensate for hearing loss. Modern hearing aids can match specific hearing loss symptoms. For example, if you have problems hearing high-frequency sounds, a hearing aid can help dial in these sounds without affecting other frequencies. Now let's examine the symptoms of hearing loss. Are your ears ringing after a day at work? On the way home, does the volume on the car radio need to be turned up higher than it was on the way into work? These are two signs of hearing loss, the result of exposure to too much noise. At first, noise-induced hearing loss affects a person's ability to hear higher frequency sounds. But since normal speech does not use these high frequencies, little hearing change is noticed. With continued exposure, hearing deteriorates, and eventually the loss spreads into those lower frequencies involved in speech. Affected individuals tend to automatically compensate by getting clues from reading lips without even realizing it. Significant hearing loss is often experienced before it is even noticed. The body's reaction to noise is similar to its response when under stress. Blood pressure and heart rate can increase, and hormone and blood cholesterol levels can change. Exposure to too much noise can make a person feel tired. High noise levels can also interfere with being able to hear important messages in some jobs, causing potential safety problems unless alternative methods of communication are used. Once hearing is lost, it cannot be replaced or repaired. It is vital that work-related hearing loss be prevented. Noise is one of the most common workplace hazards. Workers in many industries and occupations in Alberta are exposed to noise levels that are so high that their hearing can be damaged. If the sound is loud enough and workers are exposed to it for long enough, their hearing will be damaged. Fortunately, work-related hearing loss is preventable. Noise is addressed under Part 16 of the Alberta Occupational Health and Safety Code. Occupational exposure limits, or OELs, define a worker's maximum permitted daily exposure to noise without hearing protection. OELs take into consideration the loudness of the noise, measured in decibels, or dBA, and the duration of the exposure to that noise, measured in hours per day. Occupational exposure limits for noise are identified within Schedule 3, Table 1 of the Alberta Occupational Health and Safety Code. Employers in Alberta are responsible for making sure that workers are not exposed to noise that exceeds the OELs and 85 decibels. The OELs appear in Schedule 3, Table 1 of the Occupational Health and Safety Code. LEX is the worker's level of total exposure in dBA, averaged over the entire workday and adjusted to an equivalent 8-hour exposure, based on a 3 decibel exchange rate. In other words, a worker exposed to 88 decibels for 4 hours or 91 decibels for 2 hours would be exposed to 85 decibels LEX, an exposure equivalent of 85 decibels for 8 hours. Where workers are exposed to excess noise, that is, noise exceeding the occupational exposure limits, employers in Alberta are required by legislation to develop and implement a noise management program. Occupational noise is addressed under Part 16 of the Alberta Occupational Health and Safety Code. It details the legislated duties imposed on employers where preventing work-induced hearing loss is concerned. One of these duties is the implementation of a noise management program. Part 16 details the required elements of a noise management program, which include educating workers, controlling noise exposure, measuring and monitoring sound levels, conducting audiometric tests, posting of suitable signs, and evaluating the program. Let's look at each of these elements in more detail. The first and possibly the most important element of a noise management program is educating workers. Employers have a responsibility to educate their workers on how noise-induced hearing loss occurs and how workers can protect themselves. Employers are required to measure and monitor sound levels throughout their various workplaces where workers may be exposed to excess noise throughout their workday. What needs to be done to protect workers depends on the level and type of noise at the workplace. Measuring sound levels identifies noise sources and those workers most likely to be exposed to noise exceeding the occupational exposure limits. Employers are required to post hazard signage in areas where noise levels exceed the occupational exposure limits, or 85 decibels. Workers are required to utilize hearing protective devices, which are also referred to as HPDs, in areas where noise exceeds OELs. The Alberta Occupational Health and Safety Code requires employers to control the noise that their workers may be exposed to in the workplace. Worker exposure to noise can be reduced through engineering controls, administrative controls, or by providing workers with appropriate personal hearing protection. Employers in Alberta are required to provide their workers with audiometric tests. These tests help to determine the extent of existing hearing loss and to monitor for ongoing changes in hearing ability. Audiometric tests are required within 6 months of the first day of employment, 1 year after the initial baseline test, and every 2 years thereafter. Employers are required to evaluate their noise management program at least once annually. This is crucial to verifying that the program is doing what it is intended to do, preventing work-related hearing loss.